everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this integral of dx over 1 plus cos x plus sine x. This type of integral is whereby our denominator is a rational trigonometric function. The exponent of the trigonometric functions are 1. We have cos of x and we have sine of x. For this particular approach, we always consider tan of the half of angle, which is x, in this particular case, x over 2, to be equal to a new variable. Okay, but if we check in our given integral, we don't have this expression. We have cos and we have sine. How do we get the value of cos and sine? All right, we know that sine of 2 times theta is equal to 2 times sine theta cos theta. So this implies that sine of x is the same as sine of 2 times x over 2. Because I can simplify this 2 and this 2, I still go back to x. So then that means I can apply this approach, will be sine of x over 2 times cos of x over 2. All right, so that's what I'm gonna get. Now, what I can do, I can say that sine of x is therefore equal to 2 sine of x over 2 times cos of x over 2. Okay. So we have that sine of x is equal to this expression. All right, but this expression, it's all over 1. So the denominator of this expression is 1. So it's not wrong for us to say this is sine x equal to 2 sine x over 2 times cos x over 2 all over sine squared of x over 2 plus cos squared of x over 2. Because this is still 1 and goes back to this expression, because this expression divided by 1, it's still the same expression. Now, we can divide both expression by cos of x over 2. So if we do so, then we're going to have sine x will be equal, dividing here by cos, then we're going to have 2 sine of x over 2 over cos of x over 2. This cos is eliminated. We're dividing by cos squared in this particular case, because I divide here by cos, I divide here by cos, I divide here by cos squared, and I divide here as well. All right. So what is going to happen in this particular case? If we divide by cos squared, then we're going to get sine x over 2 over cos x over 2 all squared plus 1. Sine over cos is tan, so we have 2 tan x over 2 over, here we have 1 plus tan squared of x over 2. All right. We said in the beginning, tan of x over 2 is equal to a variable t. So in this particular case, we're going to have 2t over 1 plus t squared. All right. So that's what we have. Now, what about cos? How do we work cos? Okay, let's work cos then. We know that cos of 2 theta is equal to cos squared of theta minus sine squared of theta. All right. So if that's the approach that we know, then we can apply the same for cos x. So that means cos x will be equal to cos squared of x over 2 minus sine squared of x over 2. All right. Now we know that this is going to be equal. This is dividing 1. So this is the same as cos squared of x over 2 minus sine squared of x over 2 over, this is cos squared of x over 2 plus cos squared, or sine in this particular case, of x over 2. Why sine? Because they add up to 1 according to the fundamental trig formula. Now we can apply the same approach that we applied here, dividing by cos squared. So if we divide by cos squared, in this particular case will be 1 there will be minus tan squared of x over 2 over, here will be 1, plus, here will be tan squared of x over 2, which will result in 1 minus t squared over 1 plus t squared. All right, so that means we have this expression for cos of x, and we have this expression for sine of x. Okay. Okay, so after demonstrating, we concluded that sine of x will be 2t over 1 plus t squared, and cos of x will be 1 minus t squared over 1 plus t squared, when we let tan of x over 2 to be equal to t. But what will be our dx? Because in the integral, we'll always have to find what's the expression of dx. So we can isolate from this expression. We can isolate, so we're going to have x over 2 will be equal to inverse tan of t. So if we differentiate here, will be dx over 2, because the derivative of x is 1, and the derivative of tan is the derivative of the argument, which is 1 over 1 plus the argument squared times dt. So this dt can be written here. There is no problem. And then this 2 that is dividing can go this side, multiply. So this will be the expression for dx. So now I have the value of sine in which respects to t, I have the value of cos in which respects to t, and I have the dx. Remember, this dx and cos and sine, they will always be constant when we have a trig denominator of rational form, whereby the exponent of our trig expression are 1. All right, so we can just substitute. We're going to have integral. Where there is dx, we're going to have these expressions, 2 dt over 1 plus t squared over 1 plus, the expression for cos is 1 minus t squared over 1 plus t squared, plus the expression for sine, it's going to be 2t over 1 plus t squared. All right, so we just have to find the common denominator, the denominator the same. If here there is 1, that means there is the same expression dividing itself, because same expression dividing itself will still be 1. So we have the same denominator, we can just keep the denominator and operate with the numerator. So if we operate with the numerator, since the denominators are already the same, we're going to have integral of 2 over 1 plus t squared dt over 1 plus t squared plus 1 minus t squared plus 2t over 1 plus t squared. These are cancelled because they're symmetric. So we're going to have integral 2 over 1 plus t squared over 1 plus 1 is 2. So we're going to have 2t plus 2 over 1 plus t squared dt. So expression dividing itself in maths, it's keeping the first fraction and multiplying it by the inverse of the second one. So t squared plus 1 over 2t plus 2. We can factorize 2 here. So if we factorize 2, we're going to have 2 and 1 here. So this expression simplifies with this expression, this 2 with this. So we end up with integral dt over t plus 1. All right, so this is straight integral because this is ln. So we're going to have, this will be equal to ln of t plus 1 plus c. But what's the value of t? The value of t we said in the beginning. So it's the answer, it's tan of x over 2 plus 1 plus c. So this is the solution of that given problem. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.